All right. So for this lecture and or my lectures for that matter, you don't have to take down notes nor take pictures of the slides because after this, I'm going to give you my PowerPoint, also my notes. No, everything is there. So just listen and try to understand everything. Again, biochemistry is a complex subject. It entails a lot of interrelated medical concepts, and all you have to do would be just to listen and understand and digest everything. All right. This topic on bioenergetics is not an esoteric subject, meaning it applies to any other student, whether the student is a physics student, education student, IT, engineering, or other degree courses, because the subject matter encompasses all the things that require energy. So this particular subject matter deals with how do we harness energy from the food that we eat. And basically, we eat primarily because we wanted to live. Energy makes you walk, makes you talk, makes you study, makes you run, makes you dream, makes you achieve your purposes, isn't it? It helps us in digestion, respiration, absorption, okay, all other important physiological concepts. And it is for this reason that it is an important subject matter, not only for medical students, but also for other non-medical courses. All right, so we shall proceed. Can you see the first slide? All right. You've heard of Usain Bolt. Sino may kailan
Yes.
sa Usain Bolt? Kay Usain Bolt.
Yes po.
Yes, sino nagsalita? Strobo, did you,
Yes
ka
po
ba
ba?
okay, sige. Sino si Usain Bolt?
Siya po yung world record holder ng pinakamabilis pong tumakbo.
That's correct. So Usain Bolt is a retired Jamaican sprinter who is widely regarded as the greatest sprinter of all time. He is an eight-time Olympic gold medalist and only the world record holder in the 100 meter as well as 200 meter in the 2008, 2012, and 2016 Olympics. He has also won two gold medals in the four times 100 meter relay. Pero nag-retire na siya. So you can see his performance, no? And sometimes you ask yourself, what makes him tick? Ano yung nasa kanya? All right? What makes him the greatest sprinter of all time? And up to now, nobody has beaten him. All right? What is in his muscles that enables him to outrun his competitors in such a short time? Okay, we shall discover this enigma as we proceed with the lecture of bioenergetics. All right, so this will be our objectives. We shall try to define bioenergetics, differentiate between exergonic and intergonic reactions, describe the ways of coupling endergonic to exergonic reactions, relate the laws of thermodynamics to biochemical reactions, describe the structure of ATP. What else? Differentiate between actual change in free energy and standard change in free energy. Discuss the additive nature of standard free energy changes. Calculate sample problems on coupled reactions and additive nature of standard change in free energy. Describe the role of ATP, ADP cycle in energy transfer in living cells. Identify the three major sources of high energy phosphates in energy conservation, explain the metabolic roles of ATP, and define the roles of some important enzymes in biochemical thermodynamics. Okay, so this will be our objectives, and I hope I can finish the lecture in probably more than an hour or less than an hour, depending. All right. So, how do you define bioenergetics? It is the study of cellular changes or transformations accompanying biochemical reactions in living cells. In other words, in a reaction, there will be major energy changes in the cell. All right. Either the cell gives off energy or absorbs energy to be able to perform certain metabolic as well as physiologic functions. It is that's why it's called transformations accompanying biochemical reactions in living cells. Are you still following me? All right, thank you. Basically, there are two types of biochemical reactions. Oh, wait, sandali lang. All right. You have exergonic. These are spontaneous or in the forward direction because they proceed from a higher to a lower energy level, resulting to a loss or release of free energy called your Gibbs free energy or letter G. Because the reactant, because I'm sorry, because the energy of the reactants are greater than the energy of the products. In other words, exergonic reaction need no energy to begin the reaction. Hence, they have a negatively charged change in free energy, hmm, symbolized by minus delta G. All right. And therefore, they are thermodynamically favorable. They can occur. All right. And these are accompanied by release of heat to the surrounding. We call this exothermic. And therefore, exergonic reactions release heat. I'm sorry. Sorry, andali lang. Yes?
Nangingi si Perry ng ID
Ano?
ni nangingi si Kuya Perry nung ID ni Tito.
Sino dito?
Kumbal ninyo.
Bakit?
Baka hiningi sa PSA.
Nagpa-thyroid din pala si Ay, sige, i-message ko siya.
Opo, ngayon na po.
Nag-lecture ako.
O sige, okay. Bye-bye.
Ang pwede na... Sorry for the interruption. Okay. So, as it was telling, exergonic reactions release heat, and therefore, these are exothermic. The delta change or heat enthalpy or heat content of the reacting system under constant pressure is negatively charged. This is symbolized as minus delta H. And for this reason, okay, the entropy of the reaction is increased, whereas entropy is described as the disorder or chaos present in the reaction. And this is symbolized by your delta S, and therefore your exergonic reactions have positively charged change in entropy. In other words, if you talk about positive entropy, the system is in chaos or disorder. All right. Since your exergonic reactions are spontaneous, these are also called your downhill reactions, meaning it would be easy to go down a hill, isn't it? Rather than going up a hill. You don't exert energy, but you release energy. In the same manner, Sinet, if you it would be easier to go down to go down a stair, Sinet, than rather a going up a stair. In going up a stair, you have to have energy. All right. Your exogonic reactions are exemplified by catabolic or degradative reactions. No? And these are glycolysis, glycogenesis, no? Fatty acids. I'm sorry for that. Yeah, there. Degradative or catabolic. You break down, okay, molecules. Like if you break down your glycogen, that is your glycogenolysis, lipolysis, or petrolysis, beta oxidation of fatty acid, etc., gluconeogenesis, the synthesis of glucose from non-carbohydrate substrates, but the substrates came from catabolic or degradative reaction. So basically, these are the characteristics of what you call this exergonic reactions. All right. As opposed to endergonic reactions, these are non-spontaneous because they proceed from a lower to a higher energy level, resulting to a gain or consumption in free energy because the energy of the reactants would be lesser than the energy of the products, and therefore they always require energy, okay, to have the reaction. Hence, there is a positive change in free energy. All right, there is a positive change in free energy, and therefore, endergonic reactions are thermodynamically unfavorable. All right. Reactions also result from absorption of heat from the surrounding or environment, and therefore your endergonic reactions are endothermic. Exergonic are exothermic. All right. The delta change, the delta H or the change in enthalpy or heat content of the system would be positively charged. No? As opposed to exergonic reactions, as opposed to exogonic reactions, um, the entropy would be what? Negatively charged, or decreased, meaning there is less disorder or chaos in the system. All right. Again, in comparison to exergonic reactions, these are what? Uphill reactions. It would be again difficult to go up a hill or go up a flight of stairs. You have to have a source of energy. All right. Now, since endergonic reactions require energy, all right, these are exemplified by anabolic or by synthetic reactions, glycolysis, glycogenesis, fatty acid synthesis, triacylglycerol synthesis, your pentose phosphate pathway, or uronic acid pathway, your fructose synthesis, galactose synthesis, etc., etc. So these are the basic differences between endergonic and exergonic reactions. All right. The next slide shows you the what do you call this? The energy profile of biochemical reactions. Again, you're talking about exergonic and endergonic reactions. This is exergonic reaction. On the x-axis would be the time it relates to the progress of the reaction, and on the y-axis you gives free energy. All right, ascent gives free energy would be the energy that is there to be able to do work. Again, your exergonic reactions are spontaneous since energy is released to the environment without concomitant utilization. All right. Reactants with higher Gibbs free energy are converted to products via a transition state. Hence, your delta G or your change in free energy is less than zero, meaning it is negatively charged. Hmm. The release of Gibbs free energy at constant pressure and temperature is denoted as delta G is equal to the G products minus G reactants. Hence, your delta G is negatively charged. So this is the amount of energy released from the what reactions during the conversion of reactants to certain products. All right? So nag-release ka ng energy. And this is the basic definition of exergonic reactions as opposed to endergonic reactions. As opposed to endergonic reactions, for reactants to be converted to products, all right, there is an input of metabolic energy so that your reactants can be converted to the products via a transition state. By a transition state. And this represents, this represents the amount of energy or gives free energy to be able to convert your reactants into certain products. And therefore, the Gibbs free energy would be more than zero or positively charged or positively charged. All right. Clear about this energy profile of exergonic and endergonic reactions. Any questions so far about this concept? No questions? All right, let me proceed. There is such thing as coupling of endergonic with exergonic reactions. In the universe, the secret of energy flow is this. For an endergonic or non-spontaneous reaction to occur, it must obtain its energy from an exergonic or spontaneous reaction, hence the coupling of endergonic with exergonic reactions. This allows some organisms to utilize energy and resources sufficiently. All right. So here you have a reactant A or metabolite A converted to the product B. All right. With release of free energy. This released free energy now is used to convert your endergonic reaction so that your metabolite or reactant C can be converted to the product B. And the overall reaction would be exergonic in nature. All right. This release of free energy is in the form of chemical energy. And this chemical energy is now used to drive various metabolic as well as physiologic processes that require an input of energy. Now, some part of this release energy is in the form of heat energy. And heat energy is not really, I use this form of energy because this is used to maintain normal body heat. Maintain, ito yung exergonic part of your exergonic reaction. The energy expended for the purpose of generating heat is called thermogenesis. So in shivering mechanisms, the body responds to sudden cold with asynchronous muscle contractions that increase ATP utilization and energy release as heat. In non-shivering mechanisms or thermogenesis, there is less fuel oxidation to maintain constant ATP levels and thus heat is generated, and thus heat is generated. So in continuous, all right, should be coupled to exergonic reactions since these are spontaneous. In other words, endergonic reactions get their energy from exergonic reaction because exergonic reactions release energy accompanied by release of heat, and heat is used to maintain some you're not opening your camera. Sige. What is our normal body temperature? Sino ba nursing?
27
Yeah,
Celsius.
37. No, but per rectum it is something like 37.5. Temperature inside the body. So rectal temperatures would be higher 5 degrees centigrade. Okay. All right. Basically, there are two mechanisms in coupling. All right. Number one would be formation of a common obligatory intermediate. Example, to the product I until, I'm sorry, to an intermediate product until your reactants A and C are converted to the products B and D. For I, link your exergonic with your endergonic reaction. All right. And number two would be, ito. Okay. Formation of a high energy intermediate compound from end released in the exergonic reaction. All right. So your metabolite or reactant A is converted to the product B with a release of energy, right? Energy. This energy now is used to convert or what? The reactant C into the product D. All right. And this release energy in living cells is your adenosine triphosphate. If you see this red squiggle sign, it only means that this denotes that there is a high energy in that particular compound. And this energy released in living cells is what we call your adenosine triphosphate. We call this your adenosine triphosphate. This is the energy used by living cells to perform work, to stay alive, to grow, and to reproduce. Okay. All biochemical reactions follow the laws of thermodynamics. The first law, or the law of conservation of energy, states that for any physical or chemical change, the total energy of the universe or any other closed system, including its surroundings, remain constant. Meaning, energy may be transported from one region of the cell to another, and energy may be transformed from one form to another. Example, the solar energy coming from the sun is converted to chemical energy by plants during the process of photosynthesis. All right. Animals, like humans, eat the plants. And therefore, what happens? The chemical energy is converted into mechanical energy. Into mechanical energy. energy. All right. So there is no wastage of energy. It is just converted from one form to another. Now, when we take up electron transport chain, right, when we proceed further with the carbohydrate metabolism, you will learn that in the electron transport chain, the mechanical energy is converted into chemical energy. And this chemical energy is in the form of ATP synthesis. Again, there is no net consumption nor what utilization of energy, but energy is just transformed into one form or another. Hence, no energy is lost, destroyed, nor created, nor gained. Kaya nga, that's what it's called law of conservation of energy. All right. The second law of thermodynamics states that the total entropy of the system must increase if a process is spontaneously. Meaning, for a reaction to occur, entropy, which is defined as the disorder or chaos in the system, there should be an increase. Meaning, the more chaotic or the more disordered is a system or reaction, the more likely that reaction can occur. Gets nyo yun? Okay. That's the definition of your entropy. Now, to solidify further definition of the entropy here, solids like ice have a high degree of disorderliness. Okay. Liquids have an intermediate amount of entropy. Gases have the most disordered and chaotic state, especially at high temperatures. And therefore, gases have high entropy. Gases, gases are disordered. The randomness of gases are high. So that the transition from solids to liquids to gases shows an increase in entropy. No? A cluttered desk is an example of a high entropy system. Halimbawa, yung desk nyo masyadong magulo. Isn't it? So that's an example of a high entropy, as opposed to a desk or a table which is, well organized, it is neat, etc., etc. What is it? Or say your desk, this is wood, that has low entropy, isn't it? As opposed to, let's say, another table which is made of a lighter material, let's say plastic, etc. That has a what high entropy. So do you now understand the meaning of entropy? Okay. Okay, since we have talked about ATP. ATP as the high energy intermediate compound released in the exergonic reaction that is coupled to endergonic reaction. This warrants therefore a close analysis of the structure of ATP. It is a nucleotide. It is a nucleotide primarily because it consists of a nitrogenous base or a purine derivative called your adenine. This is adenine. Take a look at the numbering system of your adenine from 1 to 9. All right. Plus 3 phosphate groups, alpha, beta, and gamma phosphate. And a ribose sugar, pag sinabing ribose, 5 carbon sugar attached to the nitrogen 9 of your adenine ring, forming an N-glycosidic bond. So this is a nucleotide. If there is no phosphate group here attached to 5' carbon of your ribose sugar, this is called your nucleoside. All right. Take a look at the numbering system of the ribose sugar. This is carbon 1', carbon 2', carbon 3', in contradistinction to just the nitrogen 1, carbon 2, nitrogen 3, etc. The word prime, it refers to carbons, ribose sugar. Okay. Now, within these three phosphate groups, can you still hear me?
Dok,
Can you still hear me?
Dok, naglalag po kayo sa amin.
Okay. Naglalag ba?
Yes po, Dok.
Alright. Pero narinig nyo pa?
Ngayon, okay naman po sa akin.
Okay. So within these three phosphate groups are two high energy phosphate bonds, your gamma and your beta. The alpha phosphate bond is not a high energy phosphate bond, but it is just a normal phosphate ester. So dalawa lang ang high energy phosphate in your ATP, the gamma and the beta. All right. If you hydrolyze this, ito, ang mangyayari, you release this as Pi and you have remaining two phosphate groups and therefore this is ADP. Sorry. There, ADP. And in the process of hydrolyzing your gamma phosphate band, you release something like minus 7. On the other hand, if you hydrolyze your beta phosphate bond, and therefore this is AMP plus PPI, a greater amount of energy is released, something like minus 10.9 kilocalories per mole. All right. Now, if you hydrolyze your pyrophosphate, you yield two molecules of inorganic phosphate there. And again, you release something like minus 4.6 kilocalories per mole of energy. And these are tremendous amount of energy. Isn't it? Tremendous amount of energy that can therefore used by various metabolic and physiologic processes in the body. So that without ATP hydrolysis, you won't be able to functions. Hence, your ATP is called the common system. This is what we call the common currency of the system. Take note that the hydrolysis gamma phosphate bond is much easier than hydrolysis of your beta phosphate bond. In reactions that need transfer of a phosphate group of ATP to certain acceptor molecules, it is usually the gamma phosphate bond that is the gamma phosphate that is transferred. Because this is a weaker bond. This is a weaker bond. Any questions so far about excuse me. Of course, other high energy nucleotides are present in the body. Your uridine triphosphate, your cytidine triphosphate, and your guanosine triphosphate. Just like your ATP, these are also high energy nucleotides, but the most common would be your ATP. because this is the nucleotide that is high in concentration in comparison to the other high energy compounds. So that would be your ATP. That would be your ATP. Okay, this just a slide that shows how your ATP is hydrolyzed. So this is prime, 5 prime, the to the 5 prime carbon of your ribose sugar. Okay, you produce ADP and inorganic phosphate, and you release this amount of ATP. If this is hydrolyzed there, you release higher energy, something like minus 10 to the 9 kilocalories per mole. So the higher would be the negative value. The higher would be the negative value, the more energy. All right. If you hydrolyze adenine, okay, you release something like hydrolysis of ATP yields a tremendous amount. This is a negatively charged energy that is used to power important metabolic as well as physiologic processes in the body. Well, your ATP is to magnesium. Remember, ATP has charges ito. It is for this reason that it is complex with net because magnesium has a net positive charge. No? And alpha, beta, magnesium of ATP, beta, gamma complex of ATP. So just reaction, it is always complex with magnesium. Understood, John? Okay. Now, energy or gained or lost reaction can be calculated equation. It shows the relationship between change enthalpy and entropy of reacting system and in biologic system. Ibig sabihin, kung ano yung mga cell as opposed to standard conditions. Therefore, it is called existing conditions. And your Gibbs equation expressed by your delta G is equal to delta H minus T delta S, where your delta G would be the change in free energy of a system, or your Gibbs free energy, then is that has the capacity to do work. Your delta H will be your change in enthalpy, where H is the amount of heat transferred or emitted or absorbed in a reacting system under a constant pressure. This is a reflection of the number and kinds of chemical bonds in the reactants and products. T would be the absolute temperature in kelvins, which is equivalent to 273 plus degrees centigrade. And of course, your delta S would be the change in entropy of the universe, where S is a quantitative expression of the randomness or disorder in the system. That would be your Josiah-Gibbs equation. Now, okay, if your delta G is negatively charged, or delta G is greater than zero, less than zero, it is a spontaneous reaction. We decrease our loss in free energy, and therefore this is exergonic. It is a downhill reaction. The products formed have less energy in the reactants. If the delta G is positively charged because the delta G is greater than zero. This is a non-spontaneous reaction. It is endogonic. It is an opposite reaction. The products form have more energy than the reactants. On the other hand, if your delta G is of a chemical reaction are at equilibrium to do work. Therefore, your delta G energy predicts the direction and equilibrium position action can proceed or not. Whether the action can proceed it expresses the amount of energy derived from biochemical reaction moving way. Okay, that would be your delta G. Yeah. The reaction occurs under arbitrarily defined your change in free energy or actual mean existing conditions in the cell. Oh. So for a given reaction, reactant A and B convert to the products C and D, where your small letters A, B, C, and D are the number of molecules of your reactants A, B, C, and D, respectively. Your delta G or your actual change in energy is equal to the standard change in energy plus RT log of the ratio of the products and the reactants of the reaction. All right. Let me repeat. Your actual change in energy is equal to your standard change in energy plus RT. R will be constant. Plus, the ratio of the products of the reactants over the products of the reaction over the reactants of the reaction. Okay, so this is the formula here, where your standard change for energy, okay, would be the standard where delta G superscript 0 for the standard free energy change of the reaction and the standard conditions of temperature 25 degrees centigrade or 298 kelvins, 1 atmospheric pressure, pH of 7, and 1 molar concentration of each of the product and reactants. R would be your gas constant here, which is 1.987 calories per mole per degree. T would be your absolute temperature in kelvins, and your brackets would be the molar concentrations of the products and reactants in the reaction. So pag sinabing delta G superscript C, you're talking about standard conditions in the cell. Kaya may standard. Yes?
Doc, sorry po. Mga ganun pa rin po eh. Around 10 minutes na po.
Na ano?
Na napuputol-putol po kayo.
Ganon?
Opo.
Sandali ha. Ba't kaya? Lilipat ako lang lugar. Sandali ha.
Sige po, please. Thank you.